Okay, so let me change this real quick. The first thing we want to do when we're looking for critical numbers is to find the values at which the derivative is zero. And those values of x will tell me where the function is tapering off to a horizontal tangent, or most likely where the function is going from decreasing to increasing, or from increasing to decreasing. These points are the values where the derivative is zero. Okay. Once we determine those values, then we can look closer at each of them and say, well, what's happening to the concavity? Is it opening up or is it opening down? That will tell us really what's going on at each of these points. So let me get rid of this to clear some space. The first thing I'm going to do is get rid of, hold on 1 second. Shouldn't have added these, but okay. First thing I want to do is find the derivative of this thing. So we have f prime. Should be relatively straightforward, just the power rule. Negative 12 times 5, I get negative 60 x to the fourth. Then I have negative 4 times 75, and that's 300 x to the third. Plus 100 times 3, that's also 300 x squared. And then the 9 is just going to go away. Derivative of 9 is 0. So I'm left with this thing. So I need to figure out where this equals 0. Well, I can clean it up significantly by factoring out a negative 60x squared. So if I factor out a negative 60x squared, I'm sorry, I just said x squared, and I wrote x cubed, x squared, I'm left with first term being positive x squared. Next is going to be plus 5x. Negative 60 out of that's going to be negative 5. Okay, so I need to figure out what makes this thing 0. Well, obviously that's going to be x equals 0. And then what makes this thing 0? Unfortunately, it doesn't factor, so we're going to have to use the quadratic formula. I'll just do that real quick. We get x equals negative b, which is negative 5, plus or minus the square root of b squared, which is 25, minus 4 times 1 times negative 5. 4 times 1 times negative 5 is negative 20, so that's going to be plus 20. All over 2a, so all over 2. So this is going to give me negative 5 plus or minus the square root of 45 over 2. So we have negative 5 plus the square root of 45 divided by 2. So I get 0.8541. And then we'll do negative 5 minus the square root of 45 divided by 2. Negative 5.8541. Okay. So we know something's happening at each of these 3 points. X equals negative 5.8541, 0, and 0.8541. Now, there's a number of ways you can determine what the graph is doing at these points. We'll just stick with using the first derivative still, rather than looking into the second derivative. After I show you the first method, I'll show you the second method as well. So what I'm going to do is basically divide up a number line with these 3 values. So we'll put negative 5.8541. We'll put 0, and then we'll put 0.8541. And these are values for the derivative. Okay, so if you pick a number, let's say I'm going to put it into here, this blue version. Pick a number less than negative 5.85. I'm picking easy. easy number. So let's see here. If I do negative 10, I guess is good. So we'll do negative 60 times negative 10 squared. So that's negative 60 times negative 10 squared is going to be positive 100. And then if I plug negative 10 in here, I'm going to get 100 minus 50 minus 5. 100 minus 50 minus 5. So I get negative 6,000 times 45. You're not concerned with what the actual number is. You're just concerned with the sign. So a value over here is going to give me a negative for the derivative. Okay. Let's do this in a different color. Let's pick a number between these two, negative 5.85 and 0. Let's do negative 1. Well, I can probably do this in my head. So let's see. Negative 1, that's going to be positive. So this will give me negative 60 times negative 1. That's going to give me positive 1 minus 5 minus 5. This is going to be a negative. This is going to be negative 9 times negative 60. So that's going to be a positive number. A negative times a negative will give me a positive result. Okay. Before we do this one's going to be probably the ugliest one to do between 0 and this decimal. Let's pick a number out here. Let's do positive 10. Negative 60 times positive 100 is going to be negative. Positive 10, this will be 100 plus 50 minus 5, that's going to be positive. So we're going to have a negative times a positive, that's going to give me a negative. Okay. Now let's find one here. There's no real perfect answer. We could do 0.1. That's between those two. So I'm just going to type that out just because that's going to be some ugly math. So we'll do negative 60 times 0.1, times 0.1 squared. Nope, squared. There we go. And then I'll do 0.1 squared plus 5 times 0.1 minus 5. So I have a negative times a negative. That's going to give me a positive result. Okay. So now let's look at what's happening at each of these points. So because we've determined that the derivative is 0 at these three numbers, then we can assume that a couple things could be happening. They could be going from increasing to decreasing, in which case we have a local max. They could be going from decreasing to increasing, in which case we have a local min. Or they could be going increasing, tapering out to a flat surface, and then going up again, in which case it would be neither a max nor a min, or it could be doing the same thing in the negative direction. So what we're really concerned with is what are the slopes of the function doing? Are the slopes going from positive to negative? Are the slopes going from negative to positive? Notice the slopes here are positive. They're 0 here, and then they're negative. So the slope changes direction at a max and a min. So here the function has a negative slope. The derivative is negative, so the function has a negative slope. Then it goes to a positive slope. So this is going to look like this. Negative to a positive, this is going to be a min. At 0, we have a positive slope. It flattens out, and then positive again. So this is going to be neither. And at 0.8541, we have a positive slope to 0, then a negative slope. This is going to be a max. So I guess if you're going to start with 0, this should be neither. And then we'll plug in negative 5.8541. This will be a min. And then 0.8541. This would be a local max.